So now we will see how the proportional control action will work. What is the difference between the previous controller, that what we have discussed was on off controller, the relation the difference between that on off controller and the proportional controller, and we will discuss and we will see how to implement the proportional controller using operational amplifier. So in order to implement that, one thing we have to understand how exactly the proportional controller works. What is the relation between your input and output? Once we know the relation between the input and output, it is easy to develop or to design the circuit using an op amp. Now, so what is a proportional controller? So the name itself says that, as we have also seen in a theory session, the proportional controller is nothing but the proportionate to that of your input. The input to the system is error and the output is always proportional to that of error. So when we remove that proportional parameter, so that means the u of t is always equal to the proportionating factor Kp, right, which is also called proportional sensitivity or the gain of the system into error of t. So when we see, when we convert into Laplace transform and if you observe it, it looks something like the gain of the system. So a proportional controller is nothing but a simple gain. So proportional. So that means depends upon the error factor, the output will be always proportionally change. How much proportionate it will change, or what is the scaling factor, entirely depends upon the Kp parameter, that is a tuning parameter in this case. So if your error is higher, right, the input voltage applied to the system, to the plant, will also be higher. If the input is, the error is low, then the input, the output of the proportional control system, which is nothing but input to the plant, will always be low. So that is entirely related to your error, right, error in this case input. So that means how do we implement? So when we recall, we can either use an inverting as well as a non-inverting amplifier with proper gain. So that gain we can set by using your feedback resistance. So by using a pot as a feedback resistor in inverting or non-inverting amplifier mode, so this kind of a proportional action, control action, can be easily implemented using op amp. Now when we see, in order to realize how exactly the proportional controller works, this is a simple example similar to the previous one. In a previous case, we have seen that when the tank is almost at this position, right, then it will switch on, switch off. If it is higher than this value, it will switch off, and again if it is lower than this value, then it will switch on. You have only option like either completely on or completely off, but in this case it is entirely depends upon the level of your tank. If you see the animation very closely, so this is where we have connected our bob and this is where the valve, right. When the level is lower, there will be some flow of water into the tank or some liquid into the tank, and the amount of liquid flowing entirely depends upon the position of the bob. If the position is at the higher position, the output, the water in this case, will be really smaller, into the tank is smaller, right. So that entirely, how much amount of water is being injected into the system entirely depends upon what is the level of your float. So that means if I want to change the the gain of the system in mechanical way, so the position of this fulcrum decides, right, decides the band of your system. So for example, if A and B are equal, right, the output, this offset, is nothing but A by B into X, right. So A by B is nothing but the gain. Now what if the fulcrum is in this position? So if it is in this position, the value of A is higher and the value is B is lower, as a result the gain is higher, right. So that means if you want to understand, when the bob is at a low position, more amount of input, that means the valve will be completely at open, completely open, right. So more flow of water into the system, right. The band, if you see, it will be completely narrow. When the flow is keep on increasing, right, it will suddenly, there you can see a sudden close, sudden stop of your input, right. So that means this error band entirely depends upon what is the gain, where exactly you are using the fulcrum. Whereas if A is smaller and B is higher, the result, the gain is very smaller, it takes a longer duration, which means that the band, the proportionality band will be even higher, right. So, the proportionality band entirely depends upon what is the gain that you are using it, or in order to understand what is the current, the rate at which the current flow into our system depends upon the gain. Higher the gain, higher current initially and slowly decreases, lower gain, slowly it is, right. This is the way to just to understand the mechanical, but since in our case we have to understand about the electrical way, right. So, when we recall the input to the plant, input to the system, the controller system is nothing but error, right, error signal, which is the difference between your measured input and your desired output, set point and the actual output. So, that difference input is connected to the Kp. If the error is higher, higher input will be given as an input to the plant. If the error is smaller, smaller input voltage will be given as an input to the plant, right. So, that means we require to use a simple gain amplifier, right. So, if you see, this is a simple gain amplifier that we are using. Now, excuse me, in this case the first op amp A1, if you see, the gain of the plant is 1 excuse me, and whereas the second op amp, if you see, right. So, the input to the first op amp is error signal. So, the gain of the system is 1. So, because of that we will get a negative output voltage here. Since we require the output to be in a positive condition, we require to use another operational amplifier configuration such that the output will be always in phase with your input signal too. So, in order to do that, since we are using inverting operational amplifier, we have to go with the 2 op amps. Either gain can be set here at this point or even at this point too, one thing. And another thing is that when you observe, the output should be always 0 to 1, right, because the plant input range is only between 0 volts to 1 volt. So, in order to do that, we require to do some attenuation factor too, right. So, how do we understand this? The gain of the system entirely depends upon R6 by R5 in this case. Now, we have taken 10% of 10k, which is nothing but 1k, and R5 in this case is 10k. So, the gain is 1 by 10, right. Whereas, the gain of the first system, if you see the system, the gain is 1, right. Now, if you understand, let us take the set point is somewhere around 100 degree. When we recall what is the proportionate output voltage. So, we remember 0.1 volt per degree centigrade is the sensitivity factor, right. 1 degree will be 0.1 volt. So, since it is 100 degree, it will be 10 volts. So, that means when we are applying 10 volts as an input to the signal, meaning we are asking to maintain temperature to be 100 degree. Let us take 10 volt and the set point is somewhere around 30 degree, meaning 0.3 volt, sorry 3 volt, 30 degree meaning 3 volt. Now, the difference is how much? The difference between 10 and 3, which is nothing but 7 volts, is error. So, when I apply 7 volts here, right, the gain is 1. So, we will get an output as minus 7. Now, but minus 7 I cannot pump, I cannot give 7 volt as an input to the system, right. So, the complete range 0 to 10 volts I have to convert it to 0 to 1 volt. So, in order to do that, the gain of the system should be 1 by 10. That is the reason we are using another set of op amp, which is A2, which has a gain of 1 by 10. So, that if we are saying at 100 degree centigrade, right, it will pump with maximum, it will provide a maximum input voltage that can be provided to the plant, which is 1 volt to the plant. That is the output from the controller, right. So, that means what exactly we are doing, if I want to realize in terms of graphical way, right. So, now this is the graphical representation. So, for 0 it is at 0, right, for 100 degree centigrade 10 volt. Now, I am changing the scale from 0 to 1 volt. Why? Because 1 volt is enough, is the maximum input voltage that we can apply to the plant. So, I just simply change the scaling factor by setting the gain here. So, the gain of the system is 1 by 10, right. So, if the input is 7 volt, error input is 7 volt. So, the output will get is minus 7. So, this is minus 7. So, since the gain is 1 by 10, it will be plus 0.7 volt, 70% of full scale value. So, even we can change the gain. So, suppose if we need even if it is 7 volts, if we need higher value, we can change the gain by changing the R6 resistance value. Whether we need the same scale or a different scale can be completely understood by changing the gain value, right. So, this is our signal conditioning circuit as well as implementation of a P controller using operational amplifier. Now, why do we use this? Why do we require this R3, R4, R7 and R8 resistance? As we have already discussed previously, to compensate for bias currents, op amp bias currents. So, in order to compensate for that, we have to use the parallel combination of the feedback resistor and input resistances. That is the reason we are using the same resistance. So, understand the A1 and A2, the connections need not to be in the same fashion. Our intention is when we are applying a positive, output should also be in the same phase. So, in order to do that, since we are using an inverting kind of operational amplifier, we are using 2 op amps. The same thing can be realized using with the non-inverting type of amplifier too, where in such a cases you can simply go with simple one operational amplifier itself, right. But we have to closely select the resistance value, right, because the gain of non-inverting amplifier is RF 1 plus RF by R1. So, that is the reason. So, here in this case it is completely proportionate, we can easily understand, we can easily calculate, but if it is a non-inverting, we have to put it on a calci or pen and paper. So, that is the reason we are simply using to make it little simpler, even though by using instead of using a single operational amplifier, we are using 2 op amps. One is for changing of the phase, another one is for attenuating it, right. So, this is about P controller. Now, so in order to understand that, why do not we check in a simulation? So, this is I am going to create the same P controller. So, when we see our circuit, right. So, we are using the feedback resistor, which is of 100 kilo, and one more 100 kilo resistor as an input, right. This is the error. So, I am taking voltage source, which is nothing but my error, right. This value will be ranging from 0 to 10 volts, right. So, since the sensitivity of input, sensitivity factor of the input is 0.1 volt per degree centigrade, right. For 100 degree it will be 10 volt. If it is 200 degree it will be 20 volt, but only thing is that your op amp operating voltage should support that, right. Then right. So, we have to use combination of RF and R1 resistors at the positive terminal, so that the effect due to offset currents can be completely eliminated, sorry, bias currents, right. I need one more which acts as an attenuation. So, what I will do is that here I will take, so in this case if you see the gain of the system is 1 by 10. So, that means I am taking 1 k 10. So, either we can go with an pot or we can use a simple 1 k resistor, 1 k, and at this point it should be 10 k. So, the gain is 1 by 10. This is being applied as an input to this point, and this should be connected at this point, other terminal should be connected to negative, and we also require 2 more resistors. So, what I will do is I will copy this. How do I copy? Press a control, select whichever you want to copy and copy it here, but the resistance value should be different. One should be 10 k, other one should be 1 k. right. Now let me connect output, right. The gain is 10. So since we have applied 1 by 10, since we have applied 10, we should get 1, not minus 1. Let us see, right. Now if I change it to 1 volt, it will be 0.1, 100 milli, 0.1. If it is of 5 volts, meaning 50 degree, it should be 0.5, right, half of your range. So this is how your proportional controller. Now if I change the value, the gain value will not be in this 1 by 10 factor, it will be other factor, right. How much, what is the range with respect to the input that we have to apply, entirely decided by the gain of your system. That gain can be completely set by using the feedback resistor, right. So please understand that the use of the signal conditioning circuit at this point is to attenuate, not only to provide the proper input signal to system, it should also provide the same phase input signal to the system. If you apply negative of the same value, it is of no use. So that is the reason we are using 2 operational amplifiers to have the same phase and a feedback resistor with a lower resistance value compared to the R5 resistor in this case, so that the gain will be this will be, rather than using it as an amplifier, we can use it as an attenuator. But the factor entirely depends upon what is the resistance value that you are choosing in the feedback, which is nothing but R6, right. So one thing is clear, that the gain is 1 by 10, that we have already seen, and the phase of the system is same phase with respect to the input. Excuse me. Okay. So this is about a proportional. So now another way of implementing a system is by using proportional and integral. So if you understand, we are adding one more component into the system, which is nothing but integration. So what is an advantage of having an integration? We have seen that with respect to the proportional controller, the output will be proportionately changes based upon the error input. If the error is higher, it will always higher. If the error is lower, the output will also be lower. But if the error is constant, as long as the error is constant, it will always maintain the constant, right. But some cases we require some intelligence into the system, meaning even though if I am applying some input voltage, but the output temperature is always constant, right. So such a cases we require some intelligence, saying that yes, since there is no response change in the output, I have to add little higher value input voltage. So such an intelligence humans will always have, but when it comes to a system, how can you make that intelligence? So that intelligence can be created by using an integration. So if you recall your mathematics, what is an integration? How does an integration does? So integration is nothing but area under curve. So in this case, it not only depends upon what is the present error, it depends upon the summation of your previous error, the accumulation of an error, right. That decides the manipulated variable in this case. Whereas in case of a proportional controller, you do not have such an intelligence. It completely proportionate, input changing, error value is changing, output will change, right. What factor it is changing, what is the gain that you have set to the proportional controller, the same factor the output will change. But if there is an error between your input and output, and if the error is always constant, it cannot either pump higher value or lower value of the input voltage to the plant in order to reach to the required set point. So because it does not have any intelligence. So whereas in this case it will always count, it will always adds up. If the error is constant, the accumulation of error will be keep on increasing, as a result it changes your output voltage. So as we have already seen in the theoretical explanation by professor, so just recall. So if I say this is my threshold, sorry, this is my set point, and this is how the output is keep on changing, right, keep on changing. When you do an integration, what it does is that it will adds up the error factor. So this the dashed lines is nothing but the error output, right. So it adds up at this particular point, what is an error that I have. So that sum is 135. Now if it is keep on continuing, right. So, the error will be keep on accumulating, as a result the output will change. Suppose if it is at 60, so the integration sum will be minus 34 here and this is 135. So, the error is, so because in this case it is little higher compared to the set point, right. So, with 135 value, the quantity of 135, so it is going to more than the required set point, that means 135 is not an actual value. So, I have to decrease it. How much amount it is to be decreased entirely depends upon how much variation that we can observe here. So, as a result the value that will be applied is 135 minus 134, sorry 34, which is somewhere around 101. But if I apply this 101, again there will be some undershoot, there is some overshoot here, there is undershoot, and if you calculate the error is 7. So, 101 plus 7. So, application of 108 quantity it will maintain constant, right. In case of a proportional, if you realize, if the error is higher, the output will also higher, right. That means, if I say the error is this, output also this, error is smaller, output is smaller. It does not depends upon the accumulation of errors in case of our integration, right. So, that is the intelligence that we are creating. So, since we are using integrated system, the complexity of the system is also increasing, but how do we design? How do we design using an op amp? So, one thing we have to understand, using an op amps, any kind of operations that we can do. So, integration we can do, differentiation we can do. If you recall, the way of doing integration by simply using of a resistor and a capacitor, it does an integration operation, and it is a combination of integration as well as proportional. We have to take an adder which adds with the proportional controller and which adds with the integral controller. The addition of these two is nothing but my PI controller. If I see the complete system, if you observe that the A portion of TL084, so TL084 is a quad op amp, so it has a 4 op amps inside. The A portion of TL084 first op amp has a gain of 1, so which is acting as a P, and if you see this B portion of TL084, a resistor and a capacitor, it acts as an integrator, right. I got P with a gain of 1 and I got integrator, and the factor that the time factor entirely depends upon what is the resistor that we have chosen, right, which is nothing but 1 by RC, right. So, 1 by RC is the kg, which is nothing but the Ki, proportional integration gain, right. So, I have implemented using operational amplifier the proportional controller. Implementation of integrator using operational amplifier is done, but proportional controller is addition of P and I. So, we need to have an adder. So, this will have a negative phase shift, this will also have a negative phase shift. So, no problem. So, I am taking a negative adder, right, I am taking a negative adder. So, the output will be positive, right. So, what it does, if I say this is V1, V02, V03 will be minus of R6 by R4, since both are same resistance value, it will be the gain is 1, minus of minus V01 minus V02. So, which is nothing but V01 plus V02. So, we are getting a gain, we are getting V03 as the required PI controller output, but what is the value it will be? The value will be entirely depends upon what is the gain that we are setting here, what is the value of this, right. So, the addition of these two will be some other value, but is this voltage is good enough to pump my give as an input to the plant? May not be. Sometimes the output will be even at more than 10 volts, but I require the voltage, the range of the input voltage to be given as to be of 0 to 1 volt for the plant. So, in order to maintain that range, we are using one more operational amplifier, right, which attenuates, when you see the gain of the system is 1 by 100 in this case. Okay. So, which will attenuate that, right. So, the proportional gain is 1, the integral gain is 1 by 100, right. So, the overall gain of the system is 10 by 100, which is 0.1, because so overall gain, if I want to calculate V naught by VO3, right. So, this gain is 0.1. So, compared to the voltage whatever we get, it will always multiply with a factor of 0.1. So, that even if the input voltage somewhere around 10 volts, it will be at 1 volt. So, which will match to the plant requirement. What about the phase? If you see, when you observe the error, right, the error will be always. So, let us take this is the input, this is set point 60, 60 minus 50, 10, right. When the input is 10, this will give minus, this will give minus, this will give positive, but again this gives negative, but we require a positive. That means, we have to use one more operational amplifier which converts, which will always maintain the same phase, or rather than using a simple inverting configuration, we have to go with a non-inverting configuration with the same R7 as a pot. So, that the required gain can be set by using R7 resistor, right. So, the phase should be very much important. Okay. Now, right. So, since we have already seen integrator in the previous lectures, when we are discussing about the filter, I am not going to show anything about the anything about this, but just understand the complete working of this. So, now when we look into the board, the complete the blocks that we have discussed till now is implemented using this particular board. If you see, this is the input voltage, this is a pot, this is a pot, this is the input voltage which we are setting by using a pot. So, whatever the input voltage, like say 1 volt, which is nothing but 10 degree, 2 volt, which is nothing but 20 degree, right. That voltage we can set by using this particular knob. If I keep on changing it, the set point parameter will always change, since the sensitivity factor is 0.1 volt per degree centigrade. So, depends upon what voltage we are applying, right, will decide. Now, this is our error amplifier, right, error detector. So, error detector is a simple differential amplifier. So, what we have used is, so this is TL082. So, TL082, it has 2 op amps. One op amp is simple voltage follower, in order to not to have impedance mismatch between the output of the pot to the differential amplifier. The output of the pot is connected to the voltage follower, and the output of the voltage follower is connected to the differential amplifier, whereas other input to the error detector is from the sensor. So, what we are doing is, so this is our sensor, this is the black color one. The black color one is connected to the signal conditioning unit in the breadboard. So, if you see, this is our breadboard. So, by using another operational amplifier, we are designed a signal conditioning circuit what we have discussed in our experimental. So, the same gain, everything is set, the same resistor whatever we choose, the same resistor is even being used in this case, and the signal conditioning is set. So, as a result, the sensitivity factor of the input as well as the sensitivity factor of the sensor output will be always at the same point. So, it is easy when we do a when we do subtraction. So, that is the reason the output from the breadboard is connected to the input of the system. This input is connected to the another terminal of your op amp or of the differential amplifier. So, as a result, it gives an error output. That error output we can tap using this, right. This is small kind of a mux. So, we have different types of controllers here. So, we can see the first controller is on off controller. So, this is 180 ohm resistor that we have chosen. So, if you recall, we have used 3 resistors R1, R2, R3, right, all 3 resistors we can see, and we have used on off controller with signal conditioning circuit, right. So, since this is TL082 with a single op amp, we can design Schmitt trigger plus signal conditioning circuit. The attenuation is completely done by using this op amp, sorry, this resistor pot, right. Below this we have a P controller. So, we do have a P controller. So, P controller, this is also TL082. So, it has both op amps. So, the signal conditioning and P controller what we have seen is completely implemented using this. Other one is TL084, it has 4 op amps, we are using only 3 op amps, right. The gain is completely set by using the feedback resistor, or we can go with the initial P gain. So, we can see capacitor and one resistor which is acting as integration, right. Another pot if you see, this is another pot which is useful for the overall gain of the system, right. The completely similar to our previous one of the circuit that we have seen. So, this board also has another portion called PID controller portion here, right. So, it does both proportional summation of proportional output, integration output and differentiation output, right. So, since this is not part of our course, we are not discussing about the PID controller, right. Also, we have another op amp here. So, this op amp is a signal conditioning unit or the plant, part of a plant. If you recall, if you realize what we have discussed in the plant circuit, we have used a transistor as well as an op amp. So, that op amp is taken from this, and this is a 5 watt 0.1 ohm resistor, right. So, since I am going with minimum current of 3 volts 3 amps, I am not going with 5 watt resistor, sorry 10 watt resistor, I am going with 5 watt resistor. So, depends upon your requirement, depends upon the source requirement, we can even change the resistance value. So, what changes is the response time, how fast it is heating, entirely depends upon what is the resistor that you are choosing, right, and that is being connected to your transistor, right, the same way, right. Now, if you see the board closely, to which controller that we want to connect, right, by using this buck connectors, by using these jumpers we can decide. So, this is an error output. Suppose if I want to use on off controller, I can connect the output of this to on off controller, right. So, that this particular portion is connected to the on off controller input to this, then it gives an output here, right. Since if you connect to on off controller, the output should be connected to the on off controller like a mux and demux. If I want to use P controller, we have to connect the jumper wire between the error output to P controller, so that this particular block will be using it, right. So, to PI, if I want to use this portion, the jumper has to be connected from here to this point. Similarly, even at the output side too, from the PI to output we have to connect it, right. So, I hope it is clear the working of the placement of different components in the board. So, since we are using different operational amplifiers and the operating voltage is plus or minus 15, that completely set by using this particular RMC connector, right. So, one is plus 15, the other end is minus 15, the middle part is our ground, right. So, 3 can be connected here, so that once we connect the power supply to this, we can see turning off the LEDs. So, this LED will turn on only if you have a minus 15 connector more than minus 10 volts. This will be switched on only if sorry, this is for positive and this is for the negative supply, right. So, we will see the theoretically whatever we have seen as well as whatever we have explained, we have seen in the simulation, the same thing we will see even in our experimental too. So, rather than like I may not be completely showing you the complete block by block, but by connecting it, by changing the gain, the complete operation of a controller as well as this the controlling, how exactly the output of the controller as well as the desired output is matching with your set point, that we can see, right. So, that we will see in the next class.